Welcome. In this video, we'll be talking about how to factor a trinomial, which is a three-term expression. So notice that if you haven't watched my video on factoring by grouping, which is a four-term polynomial, go back and do that before you do this, because we're going to be using a technique that was developed in that video. So the method we're going to use to factor a three-term expression is the key number method. So what I want you to be aware of is that the method that we use for factoring is going to depend always on how many terms we're talking about. So in this case, since we're talking about three terms, that's what motivates me to use the key number method. So let's start with an example. We've got y squared plus 12y plus 35, and we're supposed to factor that. So the first step in the key number method process is to find the key numbers. So the way to find those is I'm going to multiply the two outside numbers. And what I mean by outside numbers is this 35 is an outside number. And then the number in front of the y squared, or the leading term, is also going to be an outside number. So if I multiply those together, we get 35. And the other term that I'm interested in is this middle guy. So all I'm going to do is drag him down, and I'm not, again, worried about the variable pieces. I'm just worried about the number pieces. So I've got 12 and 35. And so where those play in is I'm looking for two numbers that multiply together to give me 35, but at the same time they have to add together to give me 12. So can you think of two numbers that accomplish or meet both of these conditions? Well, what I always tell students is a good place to start is by just thinking of things that multiply together to be 35. So 35 times 1, but if I add those two together, that's not going to give me 12. So that's not going to work. 7 times 5, aha! If I add 7 and 5 together, that does give me 12. And if I multiply them together, it does give me 35. So 7 and 5 are my key numbers. I should also mention that it is really important when you're using this key number method that your terms are in order, from the highest power to the lowest power. Otherwise, it won't work. So, the second step of the process, after you found your key numbers, is to break up your middle term. Now what I mean by that is, just as we've talked about in the last video, when we're factoring, we should never really change the original expression. We change what it looks like a little bit, but we don't change its value at all. So what I'm going to do is 12y, instead of writing it that way, I'm going to use our key numbers to write it in a different way. So since I have 12y, I'm going to break that into 7y plus 5y. Notice that if I add those two together, that's still 12y, so I haven't changed what I started with. But now check out what I've got. So if I leave everything else the same, I'm now left with a four-term expression. So four-term expressions are something that we've already looked at factoring, so now we're going to use the factor by grouping technique. So we've got 1y squared plus 7y plus 5y plus 35. And if I group the first two guys together and the second two guys together, let's see if that is going to get us anywhere. So looking at the first two terms, their greatest common factor is just y, so I'm going to pull that out. So if I factor a y out of the first term, that leaves a y left over. And if I factor a y out of the second term, that leaves a 7 left over. The second group, the greatest common factor between 5y and 35 is 5. So if I factor a 5 out of the first term, I'm left with y. If I factor a 5 out of the second term, I'm left with 7. Okay, and just to check, 5 times y is 5y. 5 times 7 is 35. And now the last step is, well, let's look at what we're left with. So we're left with two terms, and they have a common group. So again, that common group makes up our first factor. And then our second factor is made up by what's left over. So we've got y plus 5. Okay, now that is our answer, but we should check it just to verify that it works. So just to check, if we distribute y times y is y squared, y times 5 is 5y, 7 times y is 7y, and 7 times 5 is 35. And so if I put the 5y and the 7y together, that's 12y, and I have exactly what I started with. So that means this checks out. Alright, let's try another one. Let's try number 2. This time I'm going to kind of abbreviate the steps a little bit. So number 2, first step is we look for those key numbers. So I multiply the outside two together, and that's 30. And I drag down the middle guy, which is negative 11. And now I have to think of two numbers that multiply together to be 30, but at the same time they have to add together to be negative 11. Well, I know for sure if I brainstorm some ideas that like negative 15 times negative 2 is positive 30, but those add up to negative 17, so that's not going to work. Negative 6 times negative 5, though, multiply to be positive 30 and add it together to be negative 11. So that means my key numbers are negative 6 and negative 5. So what that tells me is that I can rewrite my original expression and instead of writing negative 11x, I'm going to write it as negative 6x minus 5x. Okay, and let's be careful because we got to make sure we haven't changed anything. So negative 6x minus 5x is still negative 11x, so we haven't changed anything. And now I'm going to factor by grouping. So the first guy, I can factor an x out, which is going to leave, if I factor an x out of the first term, it's x is left. If I factor an x out of the second term, we've got minus 6. The second guy we can factor out, well, remember if we're leading with a minus between the groups here, I'm going to factor out negative in whatever my GCF is, which is 5. If I factor negative 5 out of the first term, I'm left with x. If I factor a negative 5 out of the second term, which was positive, I'm going to be left with negative 6. Okay, again, negative 5 times negative 6 is positive 30. So now I've got the groups in common. So my final answer is x minus 6. That's my common group. So that's the factor that leads us off. And then the second group, the second factor is going to be made up of my leftovers, which is x minus 5. And that's my answer. Okay, I want you to try number 3. Pause the video and then restart it after you've given it a try. So for number 3, again, if we get those key numbers, well, if I multiply 1 times 18, that's 18. And if I drag down the middle one, that's 9. So two numbers that multiply together to be 18, and at the same time they have to add together to be 9. So I think 6 and 3 are going to do it for us. So then that tells me that I can break up my original middle term, and instead of writing it as 9w, I'm going to break it up into 6w plus 3w. Everything else stays the same. And then I'm going to group my first two guys together and my last two guys together. So the first group, we could factor a w out, which leaves w plus 6. The second group, we can factor a 3 out, which leaves w plus 6. So then my final answer, well, the group they have in common comes first. That makes up our first factor. And then the leftovers, which is w plus 3, makes up our second group.